So what we're adding to the process, you found the axis of symmetry, we plugged it in and found the vertex, but we're going to talk about how we can use that to save time when we're setting up the table. Okay, so the equation that we're going to use is actually number 11 on your worksheet. One of the reasons I chose this one specifically is this only has 2 terms. But remember with the basics, we said, oh, you can pick the vertex out just by looking at it. Is this one of those basics, or is this different? Do we have A and B, or A and C? What do you see up there? A and B. Remember, we said as soon as B comes into the picture, it messes everything up. 8 is not the y value of your vertex, okay? So we're going to have to go through the process of finding that axis of symmetry first. So your equation for your axis of symmetry is x equals negative b over 2a. And again, I would recommend that you plug into parentheses just in case you have a negative, and that way you won't forget the negative on top, and you won't look at it as subtraction on the bottom. All right, so this happens to be A and B. When we plug in, we have negative B, which is negative 8, over 2 times A, which is 4. Okay, if there are no negatives to worry about, then that's all that much better, but this would be negative 8 over positive 8, which is negative 1. Okay, now when we were just finding the axis of symmetry in the vertex, I had to immediately go and plug that x value into your equation. You're going to still do that in a minute. But if this is the axis of symmetry and runs down the center of our parabola, that should be the center of the points that we're choosing, right? So what I'm going to have you do with this, since x equals negative 1 is the axis of symmetry, we're going to start our table to make sure we get it all filled out. And that value right there, since it is part of our vertex, is going to go in the center. So leave a couple spaces above. We're going to put negative 1 in the center of our table because that will be the vertex once we find y. Okay. Now, to build our table, we usually would do 2 spaces to the left and 2 spaces to the right. Think of it like a number line. Okay? If I were to turn this graph on its side, what would immediately be to the left of negative 1 on the number line? Negative 2, and then further would be negative 3, and then immediately to the right of negative 1 would be 0 and 1. Okay? Provided that my vertex is correct, these values should be the same for y, because they're the same distance away from my vertex. We have that symmetry, that mirror image, and these values should be the same. And for a couple of them, if you're not certain if you're doing them right, calculate the 2 on the outside. They should give you the same y value. If they do, then your vertex is fine. Okay. If you suspect something is wrong, you can always do all the calculations. If you don't have that mirror image, you've got a problem. All right. But we're going to start with the vertex. We're going to plug it in to our original equation to find y. So we have 4 parentheses squared plus 8 parentheses, and we're plugging negative 1 in place of x. Do one term at a time. We know negative 1 squared is 1. and 4 times 1 is 4. And then the second term, 8 times negative 1 is negative 8. And then 4 minus 8 is negative 4. So there's my vertex. If you have a choice between doing a negative or a positive or a smaller or a bigger number, I would go with the smaller positive number and not the negative. And 0 is a great choice if you have that option, because what happens when I plug in 0? If I square 0 and multiply by 0, I still get 0, right? And over here, I'm still going to get 0 because 8 times 0 is 0. The only time you'll plug 0 in and not get 0 out is if there's a plus c, and then you'll get out c, whatever it is. But in this case, if I plug 0 in, that's what I'm going to get out. These should be the same, so that should also be 0. And then between negative 3 and 1, I would probably use 1 because less mistakes with the negatives if you're not using them. So we're going to do 4 times 1 squared plus 8 times 1. 1 squared is 1 times 4 is 4. 8 times 1 is 8. And we get 12, so that should be 12, and that should be 12. When you consider the shape of your parabola, okay, I'm not going to graph this right now, but my parabola, remember, is a vertex, and then fairly close to that will be the next couple points, and the next couple after that will be farther away. So your vertex and the next couple points should be fairly close. They won't be right next to each other, but they should be close. And then you get a bigger jump from that value to the next. If you don't see that, that's a red flag also. Okay, question? There's only one set on. You can turn them off though if you want. Okay. So, again, the red flags that you're looking for in your table is if you get something huge, you might have done something wrong with your axis of symmetry. Go back and check your signs, check your math. If you suspect when you do those 3 that something is wrong, again, you can check one of the others, do the calculations. If these 2 are not the same, then you've still got a problem. Then that probably was not your vertex, okay? So look for those red flags in your table, and if you see a problem, you need to go back and double check some of your work, okay? We're not going to actually graph these today because I want you to just focus on those tables and getting through this process. If graphing ordered pairs is still a problem, that's something separate that we'll need to work on, okay? But if your ordered pairs are correct, graphing is a small thing to fix.